Good morning, ladies and gentlemen. I hope you're having a good, great, grand, wonderful day, and I hope this day finds you doing well. All right, we're going to talk about something totally different than we've ever talked about before. And I can't tell you, if there was any time I wish that we could be in class together, now is that time. But today, what we're going to talk about are trig graphs. Okay, trig graphs. Now, so this is going to be kind of like this slamming together of a couple worlds. Because up until now, we've known that sine theta is equal to y over r. And then once we got used to the unit circle, we kind of then equated sine theta with just y. And we've talked about cosine theta. We know that cosine theta is x over r. And in the same way, when we started using the unit circle, we knew that cosine theta was really just x. And tangent theta was kind of a combination of these two, and it was y over x. And even using the unit circle, tangent theta was still just y over x. And so we've got these x and y values showing up all the time when we're talking about trig functions. But now what we're going to do is we're going to take our trig functions and we're going to graph them. Now the problem that we run into is we graph them on an x and y coordinate plane. So it already has these letters that we have up until now used for other things. And now we're going to try to look at this from a different perspective. So what we need to do is we need to think about other more simpler functions for just a minute. So let's think of a really simple function. If I said, let's take the function f of x is equal to, and we could create some really basic function. Like let's just say 2x minus 3. We'll do a linear function. Okay, so if we have the linear function f of x equals 2x minus 3, you all know, you've had enough math that you know that you could create an x and y table. That if you wanted to know what did this look like on a graph, you could create an x and y table. And you could say, well, I'm going to plug in -2. And when I plug in -2, then I'm going to make this x and y table just a little bit more complete. So what I'm going to do is I'm going to go back to good old algebra 1. I'm going to even create that middle part. So if I plug in -2, f of x is equal to 2x minus 3. And this is going to be our y, or our f of x over here. And so what this means, that means that if I plug in -2, that gives me 2 times -2 minus 3. So 2 times -2 is -4. Minus 3 would give me -7. Okay, if I plug in 0, well, f of 0 would be like 2 times 0 minus 3. Well, 2 times 0 is 0. Minus 3 would be -3. If I plug in 2, f of 2 is equal to 2 times 2 minus 3. 2 times 2 is 4. Minus 3 is 1. Now, this should be enough points that I should come up with a decent graph. And so I can say, well, let's make my x and y coordinate plane. Okay. And we'll say our first point is at -2, -7. So that's back 1, 2, and down 7. 1, 2, 3, 4, 5, 6, 7. Okay, our next point is at 0, -3. So 0, we don't go anywhere on the x-axis, and we go down 3. 1, 2, 3. And then our last point is 2, 1. So we go over 2, 1, 2, and we go up 1. 1. And there's our line. Okay, it looks something like that. Here's our y-axis, this is our x-axis. And so this function right here can be represented by this graph right there. This is a visual representation of that function. By plugging in x values and getting out different y values, we were able to come up with these 3 points. And from those 3 points, we were able to graph this function. Now, what we're going to do is we're going to do the exact same thing, but we're going to use trig functions. Okay, so the input of any trig function, you should remember, is always the measure of an angle, but the input of every function that we graph is always x. And the output of every function that we graph is always y. So even though the input of every trig function is the measure of an angle, and the output is the ratio of two sides, now we're going to kind of change that and say, well, let's make the input x. Now, x is still the measure of an angle, and the output is going to be y. And y is still going to be the ratio of two sides, but it's just going to show up differently on a coordinate plane. So what we're going to do is I've attached a worksheet to the assignment today that you can fill out that will help you come up with some of the values. And the beginning of that worksheet looks something like this. Okay, and I labeled it sine table. And so what I'm doing here, I'm trying to create the exact same x and y table that I did right here, okay, but I'm kind of making it a little bit bigger and more user-friendly. And so what you have to do is you got to start by using a calculator. And I did the first line for you, that if x is representative of our angle and y is equal to sine of x, or f of x is equal to sine of x, then the output y is going to be whatever sine of that angle is. And so sine of 0 is 0. That was kind of easy, and I gave that one to you. But you can use your phone, you can use a calculator, whatever. But right now, what you do, if you're using a phone, you type in 15 and then hit the sine button. If you're using a graphing calculator, you hit sine and then 15 and then hit enter. And so right here, I'm saying, well, let me get off that. The y is equal to the sine of 15 degrees. And the sine of 15 degrees, now I've said rounded to 2 sig figs on my calculator, that's about 0.26. Okay, and that's it. I know you're a little surprised thinking, wait, it's got to be more complicated than that. And it's not. All I'm asking you to do initially is to just come up with some values. We're going to kind of go through this, and so let's keep going. So I say, well, 30 degrees. So if I'm using my phone, I'd say 30 and then hit the sine button. If I'm using a graphing calculator, I can say sine of 30 and then hit enter. And sine of 30 degrees, so I say y equals sine of 30 degrees. And sine of 30 degrees is exactly 0.5, or 1/2. We get to 45 degrees. I'm going to say, well, I need y is equal to the sine of 45 degrees. So if I'm using my phone, I hit 45 and then hit sine. If I'm using a graphing calculator, I can hit sine and then 45 degrees. And I get 0.7071067. And so that in terms of sig figs, is about 0.71. We'll say that. Okay? And this just keeps going right now. And this is what I'm asking you to do. I know this might seem like kind of monotonous, brainless work, but it's not. There's some things I want you to kind of notice. And so right now I do sine of 60 degrees. And sine of 60 degrees is 0.866, something. And so that becomes, if I'm rounding to 2 sig figs, about 0.87. Let's see, sine of 75 degrees. And sine of 75 degrees, y equals sine 75 degrees, and that's about 0.9659258, and so that becomes about 0.97. Now, hopefully you have noticed with me that as the angle has increased, the y value has increased, all the way to where I go, what's the sine of 90 degrees? And I don't know if you remember the sine of 90 degrees, but if you don't, plug it into your calculator, and the sine of 90 degrees is 1. That's simple. It's 1. It's exactly 1. All right? And now, what I want you to do is I want you to continue this pattern, or I'm not continue this pattern, but I want you to continue this process and fill out the rest of this sheet. All right? Now, that I want you to do on your own. Right now, what I'm going to show you to do is the second part of the assignment. The second part of the assignment is I want you to try to graph this information, just like we did before. But here, right here is our x, and here is our y. And so think about it. For this first one, my point is 0, 0. For the second one, my point is 15 and then 0.26. My third one, 30 and 0.5, and so on. And so this is what I'm asking you to do. Now you got to understand, normally we would graph this using radians, because radians are such smaller values. Instead of talking about like 180 degrees, we'd be talking about pi, which is like 3. And so this is a lot easier in terms of radians, but because we didn't learn radians until we started doing this distance learning, I know you're very unfamiliar with radians. So I'm going to keep this in the world of degrees to keep everything make sense. But what you should notice is that our x's are increasing huge, while our y's are not so much. So when we go to make a graph, we've got to make an x coordinate line that really is that includes way more values than it would normally. Okay, let me give you an example of what I'm talking about. Okay, so what we'll do is we will draw an x and y table. Okay, so I'm saying it looks something like there's my x-axis, and here's my y-axis. Okay. And let's say, okay, so here's my y-axis, and here's my x-axis. Okay, I would want you to draw a graph that looks something like this. Now remember, we're going to go all the way. If you look at the worksheet, it goes all the way to 360. So I'm going to put that right here. Go, this is 360. And here's how I'm going to come up with this. I'm going to go, what's halfway? What's halfway between 0 and 360? Hopefully everyone right now is going, well, that's easy. That's 180. Well, what's halfway between 0 and 180? Well, that's easy. That's 90. What's halfway between 180 and 360? Well, that's 270. And now we got to stop with all the halfways, and we got to think of thirds, because we want to do 30. Oh, that one's a little bit off place. Let's try that again. We want to do 30, 60, 90. 120. Oh, again, that one's a little off. 120, 150, 180. 210, 240, 270. 300, 330, 360. Okay, now I'm going to start running out of room. It's going to have to start getting really small. But so this is right here 30 degrees. This is 60 degrees. That's 90. This is 120 and 150, and that's 180. And this is 210 and 240, and there's 270. And then this is 300 and 330. But if you look at our graph that we've created, it even has half of that. So it has a half. So 15, 45, 75, 105, 135, 165, 195, 225, 255, 285, 315, 345. Okay. So this is the kind of graph I want you to create. All right. And realizing that while the x-axis goes from 0 all the way to 360, the y-axis is only going to go up to 1. And it's only going to go down to -1. Because we know that no matter what we plug in for sine, we always get some value between -1 and 1. And so we don't need to go any higher. So I'm not going to say, well, here's 1. Well, that would be foolish, because then it's going to be hard to really see this stuff well. Instead, I'm going to say, well, that's about 0.1. And then I got 0.2, 0.3, 4, 5, 6, 7, 8, 9. And this spot would be 1.0. So it would look something like this. So each one of these lines would represent a tenth. And so now my y-axis is including very few values. My x-axis is including very many values. And so then I do the same thing going down. This is just going to be -0.1. I got 2, 3, 4, -0.5, 6, 7, 8, 9, -1. Okay? Now, let's go ahead and graph some of the values. This is what I'm asking you to create right now as a table or a graph that looks something like this. And your job was to fill out this table. Now, I've only filled out from 0 to 90, and we're going to just go ahead and use that. Okay? So I've got the values like 0, 0, and 15.26. And so let's start with this. We'll just do grab the first couple of them. Let's see here. I'll graph in green. All right. So we got 0, 0, and 15, comma, 0.26. So let's go down and let's take a look at that. So 0, 0, that's easy. That's here. Now 15 is this first little dash, but my y value was 0.26. So I think about that and I go, well, here's 0.1, here's 0.2, 0.26 is going to be a little bit more than halfway to 0.3. So I'm going to say it's probably right about there. Okay, that's not too hard. Let's go back up and see what our next value was. Next value is 30 at 0.5, and then 45 at 0.71. Okay, so 30 degrees right here. Okay, and we're going to go up to all the way up to 0.5. 1, 2, 3, 4, 5. There's a dot right there. Okay, and then 45 was what? 45 was 0.71. We're going to go 45, that was right here. You go all the way up to 0.71. So here's 0.5, where the last one was, 0.6, 0.7, and just a little bit past, just a little bit above 0.7 right there. Okay, and that's what I've got so far. And I can keep going. Let's go back up top, because I've got my 60 degrees. 60 is at 0.87. 75 is at 0.97, and remember, 90 is at 1. 60 is at 0.87. So let's go down here. 60 is at 0.87. So here's 60, and we're going to go up. There's 0.7, there's 0.8, and the next one's 0.9. So it's just short of 0.9. It's about here. Okay. And we go, what was 75 was 0.97. So that's almost all the way to 1. So 75, we go up, we go 0.97, just short of 1. And then at 90 degrees was 1. And so you can see we've got this graph that is definitely not linear, and it looks something like that. And that's what we have so far. What I'd like you to do is I'd like you to complete this one graph from this one table. I want you to include the values from 0 all the way to 360. I want you to see what happens with these points as we plot them. Okay? There's plenty more data and plenty more stuff you can find online to help you through this, but I want you to just to see the basics. And so that's why I'm having you do something so basic like fill out this table. Okay, so go ahead and fill out this table. That shouldn't take you more than just a few minutes. And then what I want you to try to do is I want you to try to carefully create a graph, just like I did here, breaking it down, showing the different tick marks, the different graduations as I've shown you, and then try to fill it out for everything that's on your table. I hope this makes sense. If it doesn't, please come on to see me at Zoom tutoring from noon until 1. Y'all have a great day.